What if I told you that AI could be responsible for the next major energy crisis? Every time you ask ChatGPT a question, it burns 10 times more energy than a Google search. Training a single AI model emits as much CO2 as 5 gas-powered cars running for their entire lifetime. And here's the real kicker. AI's power demands are growing so fast that by 2030, it could require more energy than entire countries like Germany or the UK. Tech giants are scrambling to build trillion-dollar AI supercomputers. But there's a problem. Our power grid isn't ready. So what happens when AI's insatiable need for energy collides with our fragile infrastructure? Let's break it down. Imagine driving through rural America. You pass farmland, quiet homes, and empty fields. Then, out of nowhere, a colossal structure looms ahead. Rows and rows of buildings filled with millions of AI processors, running non-stop, consuming as much power as an entire city. This isn't science fiction. It's happening right now. Meta is building a $10 billion AI data center in Louisiana that will cover 2,250 acres, larger than some small towns. House 4 million square feet of AI computing power. Require 2.23 gigawatts of electricity, enough to power 2 million homes. And Meta isn't alone. In Texas, OpenAI, Microsoft, and Oracle are working on something even bigger, the Stargate project, a 500 billion AI superhub expected to consume 5 gigawatts of power, twice as much as Meta's facility. Tech giants aren't waiting for the government to upgrade the grid, they're securing energy for themselves. Microsoft is investing $80 billion into AI cloud expansion this year alone. Amazon is planning $100 billion in AI infrastructure. And Google has allocated $35 billion for new data centers in Virginia. By 2030, AI data centers will need 81 gigawatts of electricity, more than the entire state of Texas consumes today. But here's the real question. Where is all this energy going to come from? Right now, AI data centers consume more electricity than some entire countries. Experts predict that to meet AI's needs, natural gas consumption will rise by 10% just to keep up with demand. But here's the problem. Our power grid was never designed for this. The US grid was built for homes and businesses, not for AI supercomputers running 24/7 at maximum capacity. Even worse, even as AI becomes more efficient, it won't reduce energy use because of Jevons paradox. In 1865, British economist William Stanley Jevons noticed something surprising. As steam engines became more efficient, coal consumption didn't go down, it went up. Why? Because cheaper, more efficient steam engines made coal power more useful and widespread, driving demand even higher. The same thing is happening with AI. As AI chips become more energy efficient, the cost of running AI drops, making it cheaper and more accessible. So instead of using less power, we use more. This means AI's electricity demand won't slow down, it will accelerate. Some experts warn that AI could push entire power grids to failure. Could we see AI-driven blackouts? Higher electricity costs? A growing divide between those who can afford AI-powered systems and those who can't. But energy isn't the only problem AI is creating. AI is running out of cooling water. AI supercomputers run hot, really hot. Cooling them requires massive amounts of water, far more than most people realize. Training one AI model can use as much water as a small country. Some AI data centers require millions of gallons of water per day just to stay operational. In places like Arizona and Texas, AI-driven water use is causing local shortages. And yet, AI expansion isn't slowing down. To deal with the cooling crisis, tech companies are exploring new solutions. Liquid cooling, immersing AI hardware in fluids to absorb heat. Underwater data centers, putting AI supercomputers in the ocean to use natural cooling. Heat recycling, capturing AI's waste heat to power buildings or industrial processes. But even with these innovations, AI's water consumption is still outpacing our ability to replenish it. And that leads us to the final question. Can AI solve its own energy crisis? Tech companies know that AI can't keep expanding at this rate without causing major energy disruptions. That's why they're investing in solutions to make AI self-sustaining. Building data centers closer to power sources. Vantage and Microsoft are constructing facilities next to wind and solar farms. Smart grid upgrades, new infrastructure to handle AI's energy surges. AI-powered energy management, using AI to optimize power consumption in real time. Nuclear energy revival. Some believe small modular reactors, SMRs, could provide stable, long-term power for AI. Quantum computing, potentially reducing AI's energy use by orders of magnitude. But right now, AI is expanding faster than these solutions can be implemented. AI is transforming everything, but its energy demand is growing faster than we can keep up. Will AI's energy consumption push the grid past its limits? Should governments step in and regulate AI's power use before it's too late? Drop your thoughts in the comments. And if you found this video insightful, hit like, subscribe, and turn on notifications for more deep dives into AI's future.